Okay, so these are the answers to period 2. Period 1 lesson was a test which you will get the answers back to soon, but this is period 2 and these are the answers for it. So here, these are all your labels. Your pencil line is here, and it needs to be above the solvent here. And this is where your ink starts. Your ink starts on the pencil line. The solvent runs up past the pencil line, the start line, and then just moves up. There are 3 dots in this mixture, therefore there are 3 dyes. And it says, explain where the position of the original spot was. That was on the pencil line. So it always starts off on the pencil line. And this just means that we can take a measurement from the pencil line to the solvent front here. And that just means that we can take ratios of how far these dots have moved in comparison to this distance here as a fraction. So if they've moved half, then the RF value will be 0.5 because it's moved half the distance between these 2 lines. So it needs to be accurate there. It needs to be from the pencil line. So we have some questions, some answers here to some of these questions in the video. So explain what the stationary phase is. And the stationary phase is the chromatography paper because it doesn't move. It's what the mobile phase moves along. So the mobile phase moves along the paper being the stationary phase. It's important we use a pencil because pencil is insoluble, so it won't affect the results, or it won't run with the ink. Okay, so pen ink is soluble while pencil is insoluble. Okay, so good to use pencil. 5-step method is here. You draw a horizontal pencil line first, and then put 4 dyes along the line, and then along the top, and then attach a glass rod along the top of the chromatography paper, and then stand the paper in a beaker with water at the bottom. You need to ensure that the water is below the pencil line. And then after a few minutes, you can take your chromatogram out of the paper, then allow it to dry, and then draw a horizontal line where the water has ended, where the water has ended up, and that is your solvent front, because that's the front of your solvent. So it says here, what's the mobile phase? And it is the solvent that moves up. In this case, it's water, but you can dissolve things in different solvents like alcohol or anything like that. Why does the water level need to be below the pencil line? So the inks don't mix. And this question comes up a lot in chromatography, as you can see. Okay, some more questions. What does the pencil line at the top represent? That's the distance the solvent has moved, and that's called the solvent front. In the mobile phase, so the distance the solvent has moved in the mobile phase. So explain which 2 colours of the unknown dye. Explain which 2 colours the unknown dye contain. That's the yellow and blue, and that's because the dots that came from the separation of the unknown move the same distance as the yellow and blue dots. Therefore, they must be yellow and blue. It must be a mixture. So it says which colours were pure and which were mixtures. So yellow and blue, they were pure because they only had 1 dot. There was no separation, there's no mixture, it's just pure. So only contained 1 dye. Red and the unknown were mixtures as they separated into 2 dots, so made of 2 dyes. And I think the red separated into like a magenta and an orange, and then the unknown separated into yellow and blue. RF stands for retention factor, and that just tells us how well the dye has been retained on the paper. What does the RF value measure? It measures how far the dye travels in comparison with how far the solvent has moved. So however far the solvent has moved, that's taken to be a whole value of 1. The dye can't move any further than what the solvent has traveled. So the solvent has moved a distance of 1, and whatever the ink has moved, that will be a decimal, always between 0 and 1. If it's moved halfway, it will be 0.5. If it's moved a quarter of the way, the ink would be, the retention factor would be 0.25. Okay, so the equation to work out this is just the distance the dye has moved divided by the distance the solvent has moved. So the distance the solvent has moved, if it was 10 centimeters and the distance the dye moved was 5, then your retention factor will be 0.5. Okay, and that makes sense in your head, doesn't it? I think as per ratio. So it doesn't really matter if the diagram's size changes. You can still get a ruler out and measure it, and the RF values should be the same because the RF values are ratios. Okay, so these are your answers for period 3. So here's a diagram. No, the diagram's not to scale, but it doesn't matter because, as we said, we're taking ratios. So whatever values you get, they will be correct there. But it doesn't matter. So your blue value is 0.3. Your green is 0.6, and that looks about like it's moved more than halfway, and that looks like it's moved less than about a third of the way. So it sounds right. Yellow 0.9, that looks about right. It looks like it's moved a ninth of the distance of the solvent that the solvent has moved. So that sounds about right. Which dye is the most soluble? It's going to be the one that's moved the most, so it's going to be yellow. Explain how many dyes are contained in the black spot. And with the black one, we just count how many spots there are. How many spots have been separated? 1, 2, 3, 4. So there's 4 dyes because there are 4 spots. Which dyes are pure? Which dyes are mixtures? So the dyes which, sorry, I just dropped my pen. So the dyes which only have have only split into one dye, these are pure, and then this black is a mixture. So I think black is the only mixture. Black is a mixture because it's separated. Blue, green, yellow are pure. These are your questions from your Pearson book related to chromatography. They're probably a bit more realistic, or a bit more like what you'll get in the exam. So A, which of the 5 writers is using ink that matches the sample from the letter? So the sample from the letter is here. It's one of these dyes, and we just have to look for a matching pattern. So we look at here, we've got blue here. I can see the matching pattern already. It's going to be M, and that's because the dots have moved to the same distance with the solvent. So M. Which of the writers is using a pen that contains ink made from a single dye? So we're looking at ink which has only got one dot, or hasn't split. So here it's going to be R there. What is the RF value of the blue dye in suspect P's pen? So here we'd have to get out a ruler if we're measuring the RF value, and it doesn't matter about the size of this. You can just bring your ruler to the screen and measure it. It doesn't matter because it's a ratio. So even if you enlarged it, as long as you enlarge it in the right ratio, it will be fine. So RF value for subject P, the blue dot here. So we'll look at this dot from the center, and we'll get your you actually don't need your ruler because it's actually already giving you the numbers here, which is quite nice of them. So your solvent has moved a distance of 4. It doesn't matter what the units are, they'll cancel out anyway. And then this dot here is 1.8. So you'll do 1.8 divided by 4, and that should give you, it's just going to be a bit below half. What is it? It's going to be 0.45. So your dye has, and that sounds about right, your dye has moved just a bit below halfway. Which 2 of the 5 writers are using pens containing the same ink? So again, we're looking here for a matching pattern. So we had a matching pattern with the letter and with the letter sample and the M. Here I can see already that the matching samples are going to be G and T. So they're the same ink because they have the same patterns, and the dots have moved to the same distance along the paper. Whose pen contained the dye that was the most soluble in the solvent? So the most soluble is going to move the furthest, and that's going to be this orange spot here. Okay, it's a different orange to this. It's moved further. It's more soluble. It's P.